Today we're going to look at the reciprocal trigonometric functions. So we currently know about sine theta, which is the opposite over the hypotenuse in a right angle triangle relative to the angle theta. We've got cos theta, which is the adjacent over the hypotenuse, and we've got tan theta, which is opposite over the adjacent. Our reciprocal trigonometric functions are 1 over sine theta, 1 over cos theta, and 1 over tan theta. And 1 over sine theta is called cosecant theta, which we shorten to cosec theta. 1 over cos theta is known as secant theta or sec theta, and 1 over tan theta is called cot theta, which is cotangent of theta. Now cot theta seems to work fairly easily in my brain as being the reciprocal of tan theta. These two, in my head, are the opposite way round to what they should be. So 1 over sine theta is cosecant theta, 1 over cosine theta is secant theta. Now I just remember it because it goes against instinct, so I remember it as being the opposite of what you would think. But there is a way of remembering it, and that is that 1 over sine theta is cosec theta, and S is the third letter of cosec. C is the third letter of sec, so that's 1 over cos theta, and T is the third letter of cot, so that's 1 over tan theta. So the third letter of these reciprocal trig functions tell you which function they are the reciprocal of. And it's quite easy if we want to work out cosec of, say, an angle like pi over 6. Pi over 6 is 30 degrees, and I know that sine of 30 is a half, so cosec of 30 is 1 over a half, or the reciprocal of a half, which is 2. If I want sec of 45 degrees, or pi over 4 radians, I know that cos of pi over 4, or cos of 45, is 1 over root 2, so sec will be the reciprocal of that, so just root 2. Let's say I want cot of 45 degrees, so cot of pi over 4. I know that tan of pi over 4 is 1, so cot of pi over 4 is the reciprocal of that, which is also 1. So we can work out these values just by taking the reciprocal of the corresponding trigonometric function sine, cos or tan. Now we do need to know some identities to do these with these reciprocal trigonometric functions. We know two identities from our year 12 work. We know that tan theta is sine theta over cos theta. So that will tell us that the reciprocal, so 1 over tan theta or cot theta, is cos theta over sine theta. So that one is really easy. The reciprocal of tan theta is the reciprocal of sine theta over cos theta. The second identity that we know from year 12 is that sine squared theta plus cos squared theta equals 1. And to get our corresponding reciprocal identities, we're first going to divide all of this by sine squared theta. And that gives us sine squared over sine squared, which is 1. Cos squared over sine squared, that's the same as cos theta over sine theta all squared. So that's cot theta squared, cot squared theta. And then 1 over sine squared theta, that's 1 over sine theta all squared, which is 1 over sine theta all squared. So that would be cosec squared theta, cosec of theta all squared. And then to get the final identity, we do exactly the same as what we've just done with our sine squared theta plus cos squared theta equals 1. But this time we divide the identity by cos squared theta. So this time we've got tan squared theta plus 1 equals sec squared theta. So those identities don't need to be remembered. I can't remember them, but we can derive them every single time we need them. It takes us 2 seconds to work out what they actually are. So my recommendation is don't try and fill your head full of them, but just remember how to derive them from your Year 12 knowledge. Okay, let's have a look at some examples of using this. So let's look at the notes. Now the start of the notes just talks about what we've already talked about, and then the examples are to do with solving equations using this knowledge. So question 1 is solving a quadratic equation in terms of cot theta. So we've got cot squared theta minus 3 cot theta plus 2 equals 0. Now you can either solve that straight away on your calculator, so by going into the equations option, which is option A, and it's a quadratic, so a polynomial degree 2. We've got 1 of the squared variable minus 3 of the variable and 2 as our constant, and it will give us the values 2 and 1. Remember, you could also factorise that. It would factorise to cot theta minus 2, cot theta minus 1, and then you can get your 2 and your 1. So it's up to you whether you do it manually or do it on a calculator. So we've got cot theta equals 2 and cot theta equals 1. This is where we use what we know about reciprocal functions. So cot theta is 1 over tan theta. And if I take the reciprocal of both sides, that gives me tan theta is a half, or tan theta equals 1. Tan theta equals 1 is one of those common values that we should know. So theta is, we're working in degrees, so 45 degrees. And tan theta equals a half is not a common value, so I'm going to use my calculator, making sure I put it back into degrees because I've been working in radians. So I want tan inverse of a half, and that gives me 26.6 degrees. Remember to get all of the answers within your range. We're working from 0 to 360, and tan repeats itself every 180 degrees. So I can add 180 to both of those answers. To give me all 4 possible roots of the equation. Let's have a look at question 2 next. Solve the equation cosec squared x equals 2. So I'm going to start by working out cosec. So cosec x is the square root of 2, but remember to consider the positive and the negative roots. Cosec x is 1 over sine x, so that means that sine x is the reciprocal of this. So 1 over plus or minus root 2. Now, 1 over root 2 is one of the values that we should know. And it's 45 degrees, except this time we should be working in radians. So it's pi over 4. And then don't forget to consider all our possible solutions. So we're working between 0 and 2 pi. So for sine, if we've got pi over 4, we will also have pi over 4 on from pi over 2, or back from pi, which gives us 3 pi over 4. And then if we work with sine x equals minus 1 over root 2. Now if you type that into your calculator, it will give you this value here, minus pi over 4. Remember that sine repeats every 360 degrees, or every 2 pi radians. So we will also have a value at 7 pi over 4. And then let's get our other value, which is here. So it's pi over 4 back off onwards from pi. So that's 5 pi over 4. So those are our 4 values. So although we're working in radians, we can still use our trig graph to help us to work out those extra roots. So really the only new thing in today's lesson is getting to the point where we're working with sine, cos or tan. We don't have to actually solve the equation in terms of cosec or cot or sec, because we can convert it into one of the questions that we're used to seeing. Let's look at part B next. Hence solve cosec squared 2x equals 2. So this is the same equation but with 2x instead of x. So it will have the same roots, except these roots will be for 2x instead of x. We wanted x between 0 and pi. So we want 2x between 0 and 2 pi. So it is exactly the same question with exactly the same range, other than replacing the x with 2x. So these answers that we got here are now for 2x. So for part B, 2x is pi over 4, 7 pi over 4, 3 pi over 4, and 5 pi over 4. So x is pi over 8, 7 pi over 8, 3 pi over 8, and 5 pi over 8. Okay, let's have a look at some more difficult examples. So question 3, we are looking at sec of a compound angle, sec of 2x minus 10 equals 4. Remember, we solved this in exactly the same way, but we're going to be using a different range. So if x is between 0 and 360, 2x minus 10 is between 2 times 0 minus 10, so minus 10 degrees, and 360 times 2 minus 10, so 710 degrees. So we need to adjust our range to deal with the adjusted angle. Sec of 2x minus 10 is 4, so if I take the reciprocal, then cos of 2x minus 10 is a quarter. And we can work out our first angle by doing inverse cos of a quarter. Let's just make sure my calculator is in degrees. So I get 75.5 degrees. So remember, that's this angle, the 2x minus 10 is 75.5 degrees. Then I need to consider any other angles in the range. So I need to go all the way to 710 degrees, so just before my 3rd peak of the graph. So if I've got a value at 75.5 degrees, I will have a value at 75.5 degrees back from 360. It's 75.5 degrees on from 0, so it's 75.5 degrees back from 360. So that's 284.5 degrees. And then once you've got your two values between 0 and 360, you can get your next two just by adding 360 onto each of these. So we get 435.5 degrees, and we get 644.5 degrees. Don't forget that's 2x minus 10. So to get 2x, we need to add 10 onto all of these, and to get x, we need to half that number. So we're adding 10 and then dividing by 2. So we get 80.5 degrees. $147.3 degrees, 222.8 degrees. And finally 327.3 degrees. Okay, the next two equations require the identities that we looked at. So in question 4, your equation is in terms of two trigonometric functions, sec squared x and tan x. However, we know from the identities that we looked at that sec squared x can be written as tan squared x plus 1. So we're going to replace the sec squared x with tan squared x plus 1. So this is tan squared x plus 1 minus tan x equals 1. If I subtract 1 from both sides, that gives me tan squared x minus tan x equals 0. I can type that into my calculator as a quadratic with 1x squared minus 1x and 0 constant, or I can factorise it, taking out the common factor of tan x, and it gives me tan x is 0, or tan x minus 1 equals 0. So tan x is 1. And tan x is 0, I know from my graph, at 0 radians, and then 180 degrees later, so at pi radians, and then another pi radians further on, so at 2 pi as well. Just check my range does include the 0 and the 2 pi, so I need to write all three of those down. And then tan x equals 1 is one that I should know. I know that tan of 45 degrees is 1, or tan of pi over 4 radians is 1. So pi over 4 will be a solution, and then remember that we can add 180 degrees pi radians to get our other roots. So that would give me 5 pi over 4 radians. If I add another pi, it's going to take me beyond 2 pi, so those are the only 5 roots of the equation. Question 5 contains cot squared theta and cosec theta. Now, looking at my identities, I can see that cot squared theta is cosec squared theta minus 1. So it's this identity with 1 subtracted from it. So I can substitute that into the equation. So where I have cot squared theta, I'm going to write it as cosec squared theta minus 1. Take away 3 cosec theta plus 3 equals 0. So that gives me cosec squared theta minus 3 cosec theta plus 2 equals 0. So you can type that into your calculator with using the quadratic equation solver with 1x squared minus 3x and 2, or you can factorise it, and it's the same as the one we did earlier. It will factorise to cosec theta minus 2 and cosec theta minus 1, giving us cosec theta equals 2 and cosec theta equals 1. So that tells us that sine theta is the reciprocal of that. So a half or 1. Now I know that sine of 30 degrees is a half, so that gives me theta is 30 degrees. And I know that sine of 90 is 1. I only need theta between 0 and 180. So if I look at the sine graph between 0 and 180, there's only one value for sine theta equals 1. There's 2 values for sine theta is a half. So if it's 30 degrees, it's also 180 minus 30, so 150 degrees. So we have 3 values of theta there.